I want to get to the order of operations here. And the only distinction that's really, really valuable for our future purposes is in chapter 4. And you might be asking yourself, my gosh, where is this coming from? Chapter 1 was so broad and so full of concepts. And then we're getting into something that appears to be pretty darn mathy, if you will. The reason that we're exploring this is because this will come to play when we're doing standard deviations in chapter 4. So it's a matter of sort of putting our flashlight batteries in the flashlight before we get to chapter 4. You can see 4 numbers on the left there. 3, 1, 7, 4. And if I were to add them all up, of course, that'd be 15. 3 plus 1 plus 7 plus 4 is 15. Sigma x in parentheses squared. Now, what does the character sigma mean? And this is the uppercase sigma. The lowercase sigma sort of look like an O. Uppercase sigma x means the sum of all the values. That's it. So the sum of 3 plus 1 plus 7 plus 4 is 15. If I place that value in parentheses, that denotes that I'm going to take that sum and square the sum. So 15 squared, as you knew off the top of your head, of course, is 225. 225. On the other hand, when I list sigma x squared with no parentheses in sight, that means I'm merely going to take all the values and square them, then add up those squares. So I square 3, get 9, square 1, get 1, square 7, get 49, square 4, and get 16. And when you add those numbers up, of course, it comes to 75. And let's double check that. 10 and 49 is 59, and 16, of course, is 75. So that's 99% of the distinction that needs to be made from this section of the chapter. When we place sigma x in parentheses, that means take the sum of all the numbers and then square that. When we have sigma x squared with no parentheses, that means take the square of all the numbers first and add those squares up. Add up all of those squares. And that's most of our concern. That's just about it. Those two skills, that differentiation is what's needed in order to solve problems in chapter 4, which we'll do not necessarily by hand, but sort of in a rudimentary fashion. Here is another example. The two most critical orders of operation are, as we say, you can see that sigma x equals 17, 10 plus 5 plus 2 plus 0, 17. If I put that 17 in parentheses, sigma x in parentheses squared is 17 squared, which again you knew off the top of your head is 289. I'm kidding, of course. And then the other treatment is I square all the numbers first when I see no parentheses and add up those squares. 100 plus 25 plus 4 plus 0. By the way, this is as good a time as any to mention this. If we were to have a negative number, when we square a negative, it's always positive. For some reason, that comes up a lot. When we square negatives, we don't know what to do with them. But when we square a negative, that's always positive. Just please bear that in mind. Well, that's about it. I mean, your text goes into a lot more detail on sorts of problems like this, but this is 99% of the purpose, is to differentiate sigma x in parentheses squared when I take the sum of all the numbers and then square it, versus sigma x with no parentheses when I square all the numbers first and then take the sum of those squares.